let's talk about a weirdly modern kind of car crash. You know, the scene is tragic, the investigation is intense, but when they dig into it, they find something strange. No part of the car actually failed. The brakes, they worked. The steering, totally fine. The sensors were all online. So, how in the world did this happen? It's a puzzle that's completely changing how we think about car safety. Now get this. This isn't some line from a sci-fi movie. This is a direct quote from the National Transportation Safety Board. It's from their report on a fatal crash back in 2018. The car was working exactly as it was designed to. And that one sentence, it just opens up this terrifying new kind of accident that we're all facing now. So that's the big question, right? If it's not a broken part, it's not a software bug, then what is it? Well, the answer isn't simple. And to find it, we've got to go deep into this really complex and honestly, often broken partnership between human drivers and their super smart cars. Turns out, this whole mystery of a crash without a failure, it actually has a name. And there's an entire international safety standard built specifically to solve it. It's called SOTIF. And yeah, it's a bit of a mouthful. It stands for Safety of the Intended Functionality. What SOTF does is it completely shifts the conversation. We stop talking about system failures and we start focusing on system limitations. And, this is the really important part, something called reasonably foreseeable misuse by the driver. So, SOTIF breaks this misuse idea down into two main types. First, you've got direct misuse. This is when you actively choose to do something wrong, like using a highway-only system in the middle of a busy city. But then there's indirect misuse, which is way more passive. It's when you just stop supervising. You fail to take back control when the car needs your help, which is exactly what happened in that crash we just talked about. So here's the bottom line. We're not looking for a broken part on a car anymore. We're investigating a broken partnership. The real problem is in that fuzzy, unpredictable, and complicated space between the person and the machine. Okay, so if the problem is this broken partnership, you have to ask, why do smart people do these seemingly reckless things? I mean, why would you overtrust these systems? Well, to figure that out, we have to dive into the psychology of it all. A lot of the time, it starts with something called a mental model mismatch. We all build these little models in our heads for how technology works. The problem is when our model is just plain wrong. If you believe your car is fully self-driving, when in reality it's just a really advanced assistance system, you're going to make some seriously dangerous assumptions about what it can and can't do. And this is where things get really weird. It leads to this dangerous paradox. Think about it. The better a system is, the more flawlessly it works, the more we trust it. And the more we trust it, the less attention we pay. They call this automation complacency, and it's a massive reason for that indirect misuse. The system's perfection is actually what makes us worse drivers. You know, there's a well-known psychological principle that explains this perfectly. Basically, our ability to react and think clearly is at its absolute best when our brain is moderately stimulated. Not panicked, but definitely not bored either. And here is the problem. A super automated car that handles, say, 99% of the driving for you, it pushes your brain right out of that peak focus zone in the middle and way over into the boredom zone on the left. And when you're in that low arousal state, your ability to suddenly snap back to attention and handle an emergency, well, it's pretty much shot. So, enough with the theory. Let's take a look at how these psychological traps have actually played out in the real world by looking at some of the most infamous crashes of the last decade. First up, let's talk about the 2016 crash in Florida. This was one of the first huge incidents that really put a spotlight on the dangers of overtrusting these systems. This case is like a perfect storm of everything we've been talking about. The system had a known limitation. It had a hard time seeing a white truck against a bright sky. But the driver, probably influenced by that very confident name, Autopilot, had a totally mismatched mental model of what the car could do. That created these completely inappropriate expectations, and it led to a fatal over-reliance on a system that was never, ever designed to be perfect. All right, next. The tragic 2018 Uber test vehicle crash in Arizona that killed a pedestrian. This case is a textbook example of automation complacency. There was a safety driver behind the wheel, but they weren't engaged at all. Why? Pure automation complacency. After who knows how many hours of the system working perfectly, the driver's brain just switched off. They were deep in that low arousal boredom zone we saw on the chart, completely distracted by a TV show, and they failed at their one job, to be a supervisor. So as these incidents started piling up, engineers knew they had to fight back. And what happened next was this fascinating cat and mouse game between users who were misusing the systems and the engineers who were trying to predict and prevent that misuse before it happened.
And how they do it might really surprise you. This isn't just work in a lab. Safety engineers have basically become digital detectives. They are systematically scraping social media, YouTube, TikTok, you name it, looking for videos of people hacking their own cars. They then take that real-world misuse, simulate it in a digital world, and design countermeasures to stop it.
Now, this led to a huge shift in philosophy. For years, engineers drew a really clear line. They said misuse, that's our problem to solve. But abuse, like deliberately trying to defeat a safety system, that was the driver's fault. Well, that's changing. The new philosophy is, if abuse is predictable, it becomes the manufacturer's responsibility. If you know people are going to try to stick a water bottle on the steering wheel to trick it, it's now your job to build a sensor that can't be tricked.
And this whole engineering counterattack leads us straight to the future of car safety. Systems designed not just to watch the road, but to watch the driver. The first line of defense is something called driver state monitoring, or DMS. But we're not just talking about a simple check to see if your eyes are open. The new systems use cameras that face inward, and they track where you're looking, how often you blink, even how dilated your pupils are. They're trying to figure out if you're mentally checked out, even if your eyes are pointed straight ahead. And to combat that direct abuse we talked about, the hardware itself is changing. Forget those old sensors that just felt for a little bit of pressure. The new standard is capacitive steering wheels. Just like your phone screen, they actually detect the electrical charge in your skin, which makes them pretty much impossible to fool with a water bottle or an orange. That little arms race, it's ended. So what happens if the cameras see you're not paying attention and the steering wheel knows your hands are gone? That's when the car's final safety net kicks in, the minimal risk maneuver. After a bunch of warnings, the car will literally take control, turn on the hazards, and bring itself to a safe stop. It's the car deciding the partnership is over and it's time to step in. And all of this, monitoring our gaze, sensing our touch, taking control of the wheel, it all points to one final huge question. As our cars become undeniably smarter, are we, as drivers, really ready for the day when they have the authority to judge us? To judge our attention, our focus, our fitness, and ultimately our very permission to drive?